Let's start doing some problems involving ellipses. This first problem, we're given the equation of an ellipse and we're asked 3 questions and then we're asked to graph it. So it's x squared over 49 plus y squared over 16 equals 1. So we're asked to find the center, the vertices, and the foci, and then to make a sketch of the graph. First thing you have to do is figure out which of the standard equation you're going to use for this problem. So here are the 2 ellipse equations from the formula sheet. They're identical, except you can notice that for this one, the x term is with the a squared, this one the y term. Now the a squared denominator is always larger than the b squared, so we look at ours. Obviously that's a squared and that's going to be b squared, and in that case this kind of ellipse is a left or right ellipse. This is the equation for a left or right ellipse. This one is for up or down. So I know we have a left or right ellipse. Let me go and write the standard equation for the left or right ellipse is x minus h quantity squared over a squared plus y minus k quantity squared over b squared equals 1. So by simply comparing these 2 equations, the center of the ellipse is HK. You can see up here actually there aren't any parentheses, which means H and K are both 0. So the center of this ellipse is at the origin. The major vertice is based upon the value of A equals 7, and let's go ahead while we're doing this, B equals 4, and now we have everything we need to sketch the graph of the ellipse. So let's sketch the graph, then we'll fill in the value of the vertices, and then we will have to do one more calculation to find the foci. So if I'm going to sketch the graph, the center, since this is a left to right ellipse, I know the distance from the center to the vertice is going to be 7. So I have to go to the right 7 and to the left 7. So these are going to be the vertices. This is how wide the ellipse is going to be. And then the minor vertices, since B is 4, move up 4 and down 4. So the ellipse looks something like this. Drawing ellipses can be a little tricky. So the center is 0, 0. The 2 vertices, this one is 7, 0. This one is negative 7, 0. Now the foci are inside the ellipse on this major axis, and the equation for the foci, which is actually on the formula sheet for an ellipse, c squared equals a squared minus b squared. And c is going to be the distance from the center to each of the foci. So a squared is 49, b squared is 16, c squared is 33, but we really need to know what c is equal to, so take square root of both sides. So we're not required to graph the foci, but just to do it, let me see what the square root of 33 equals. It's got to be a little larger than 5, 5.7. So if you graph the foci here, you would move 5.7 to the right. 1, 2, 3, 4, 5. So maybe there's a foci and the same distance to the left. So the actual foci as points would be, if we do this in first, negative square root of 33, 0, and then square root of 33, 0. All right. Let's look at the next problem. Here I'm not going to actually do the whole problem. I just want to start it out, because once we look at something briefly, then it will be just like the last problem. Here's the equation of an ellipse. 4x squared plus y squared equals 100. Now I didn't mention it on the last problem, although I should have. The very first thing you do when you're given the equation of an ellipse is to make sure it's in standard form. And the key is, standard form for an ellipse means one side of the equation has to equal 1, and you can't have any coefficients in front of the squared terms. If you look at the standard equation, for both these, one side is 1, and if you have any numbers, they have to be in the denominator of the fractions. So this is not in standard form, so the first step is to rewrite this equation so it's in standard form. What I'm going to do is, since this needs to be 1, I'm going to divide everything on both sides by 100. Now 4 over 100 is 25, or sorry, if I reduce this 4 over 100 reduces to 1 over 25. So now this equation is in standard form, and just to make it clear, normally we always just write the larger denominator first. You don't have to, but just to make it clear, because now the standard equation, once again, this is a squared and this is b squared. So the standard equation would be y minus k quantity squared over a squared plus x minus h quantity squared over b squared equals 1. And this is the equation for an up or down ellipse. So we're going to have up or down ellipse. I'm not going to finish this problem because it's just like the last one at this point. Up or down ellipse. Looks like the center is at the origin 0, 0. You have your A and your B, and you would go off and do the same thing. What I wanted to do was show you the first step because the original equation was not in the standard form. We had to do some work to get the equation in standard form, and then we were good to go. However, I will do one more from start to finish. So here's the equation for this ellipse. X minus 4 squared over 64 plus y plus 1 squared over 4 equals 1. All right, first question, is this equation in the standard form? And yes, it is. Matter of fact, if I write the standard equation, it would be x minus 8 squared over a squared plus y minus k excuse me, squared over b squared equals 1. So this is actually the equation of a left to right ellipse, since the x squared term is above the a. The center, which we're asked to find. So here's the case where my little method of finding these correct numbers is, I know h is up here with the x. I take the number plus the sign in front of it. So that's -4. And when I come down here, I write the opposite. For the k, I grab this +1 and I make it the opposite. So actually the center is going to be 4, -1. This is a squared, so a is going to be 8. B squared is 4, so b is 2. And now I have what I need to sketch this ellipse. And then, like the other problem, at the end we will go ahead and calculate the foci. So the center is 4, -1. Now I'm going to have to move 8, so let me do this. Let's go 1, 2, 3, 4, 5, 6, 7, 8. Here's 10. So 4, -1. Four, -1. So there's the center of the ellipse. Now for my major vertices, I'm going to, from the center, move to the right 8 and then to the left 8. So to the right 8 puts me out here at 12. And to the left 8 would put me at -4. These don't look like the same distance. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. Well, this is the idea. When you do a rough sketch, sometimes things aren't always looking perfect, but I think I have stepped them off correctly. Because this point here is this is a major vertex, 12, -1. And this one here should be -4, -1. And the center here is at 4, -1. Up and down, I'm going to move 2. so once again, I apologize. This distance obviously looks longer, but these should be, you know, just because it's bugging me. Maybe I'm a little of a perfectionist. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then 1, 2, 3, 4, 5. See if I can make this look a little better. So the center is 4, -1. And then the vertex, you go out here, and then you go over here, and you go up 2, down 2. Now this looks a little better. It's not a beautiful ellipse, but at least the center looks like it's in the middle. Okay, so from up above, we said the center is 4, -1. Now the vertices, we started at 4, -1. We moved 4 to the right. So that's 12, -1. And then 4 to the left, which put us at -4, -1. Now for the foci, we have to find that distance c. So for ellipses, c squared is a squared minus b squared. So a squared is 64, b squared is 4. So c is going to be square root of 60, which we can actually simplify as 4 times 15. So 2 square root of 15, I'm going to move from the center the distance 2 square root of 15 to the right and to the left. So hopefully you can see that the foci, I'm starting here at x is 4, and I have to add 2 square root of 15 to get to my first foci. I can see what that actually equals. 15 square root times 2 equals 7.7. 1, 2, 3, 4, 5. So it's almost to the vertice. But then the other direction, I start here at 4 and I have to subtract 2 square root of 15. All right,